Exercise 3b, question 18, we're asked to consider the convergence of this series here. Because it's got factorial in it, the classic test uses, of course, the ratio test, and you'll see that I've set up the ratio test for this problem, and now it's just a case of processing through. So let's begin. The limit as k approaches infinity of, that will become 4 to the power of k plus 2 over 3k plus 3 plus 1, so 3k plus 4 factorial, and then over here we've got the 3k plus 1 factorial, and underneath we've got the 4 to the k plus 1. So let's simplify further. That will be the same as the limit as k approaches infinity of, well, first of all we can see if we deal with 4 to the k plus 1 and divided by 4 to the k plus 1, we essentially just subtract the powers, and so we're going to be left with just 4 to the 1 on top. And if we consider what 3k plus 4 factorial looks like, it's 3k plus 4 times 3k plus 3, sorry, 3k plus 4 times 3k plus 3 times 3k plus 2 times 3k plus 1, etc. And anything below, from 3k plus 1 and below, will cancel out with that 3k plus 1 factorial on the top. So hopefully you can see we're just going to be left with 3k plus 4 times by 3k plus 3 times by 3k plus 2. Right, I think the next job is to divide throughout, so let's do that next. And I think this time we'll divide throughout by k cubed will do. So on the top 4 over k cubed, and then on the bottom we're essentially going to consider 3k plus 4 over k, 3k plus 3 over k, 3k plus 2 over k. Simplifying further, the limit as k approaches infinity of 4 over k cubed, and then we're going to have 3 plus 4 over k, 3 plus 3 over k, and last but not least 3 plus 2 over k. And then in the limit as k approaches infinity, this is going to be equal to, on the top 0, underneath 3 plus 0 times 3 plus 0 times 3 plus 0, which of course gives us 0, which is less than 1, and again we can say by the ratio test the given series will converge. Okay, for part B, what we'll do is we'll break this up into two separate fractions. The first one being 3k factorial over 3k plus 1 factorial plus the summation from k equals 1 to infinity of what we've actually just dealt with in the first part. So straight away we can say that this part at least is convergent, and the question is what will happen here. My immediate suspicion is it looks like it's going to be divergent. Let's see. Well, if we think about this, on the bottom it's 3k plus 1 times 3k times 3k minus 1, etc, etc. Hopefully you can see that the 3k factorial on the top will cancel out nearly everything from the denominator, and in fact we'll be left with just this, which looks suspiciously like a harmonic series. Okay, so what we're going to do here, we're going to use the limit comparison test, I think. So if I let an equal 1 over 3k plus 1, and I let bn equal 1 over k, which we know to be divergent, then we will simply now have a look at what happens when we do an divided by bn. Well, if we do that, we'll get 1 over 3k plus 1 times by k over 1, which gives us k over 3k plus 1. And now we consider what happens as k goes towards infinity. So the limit as k goes towards infinity for this one, let's divide throughout by k. We're going to get 1 over 3 plus 1 over k, which in the limit will go towards 1 over 3 plus 0, which is 1/3. And by the limit comparison test, because we know that our function bn, which was 1 over k, was divergent, and the fact that the limit as k goes to infinity of an over bn actually equals the limit of 1/3, that means that either both of our series are convergent, which we know is not the case, and therefore we can deduce that they both must be divergent. So therefore the series part from here is divergent, and therefore what we essentially have in this problem is the summation of a divergent part and a convergent part, and I think it's fairly obvious that the overall result must be one of divergence. So therefore the given summation this time, which was this, is divergent.